welcome everybody. My name is Professor Graham Nicholson. I'm the Associate Dean International in the Faculty of Science here at UTS. And today we're going to talk about undergraduate programs offered by the Faculty of Science. So 75% of the fastest growing occupations require what's known as STEM skills and knowledge. So STEM is science, technology, engineering, and mathematics. And if you choose an undergraduate program in the sciences, then you can take full advantage of this growing requirement in the STEM area. STEM also has one of the lowest unemployment rates here in Australia. The dark blue bars shown here indicate that the STEM graduates have an unemployment rate of around about 3.7%, as compared with over 8% in individuals who don't have any post-secondary qualifications, and significantly above non-STEM graduates as well at 4.1%. In terms of future employment growth, this graph here shows the projected employment growth out to 2023, although I must give the proviso that this data was taken before the outbreak of the COVID virus. But as you can see, back in 2019, the professional, scientific and technical services area, which STEM falls under, was expected to undergo a 10.2% growth in employment, one of the highest of all discipline areas. And finally, the undergraduate starting salaries is often a misconception that science undergraduates earn very poor starting salaries. And here you can see that science and mathematics graduates earn on average 61,000 as a starting salary, and that's about average for all discipline areas. So I'm going to now talk specifically about the UTS Science faculty and some of the programs we offer at the undergraduate level. First of all, the medical and molecular biosciences area, which is probably our biggest area. The environmental sciences, chemistry and our forensics program, physics and nanotechnology, mathematics and statistics. And we have over 60 courses at the undergraduate and postgraduate level in the coursework area, as well as our research degrees in Masters and PhD. So why would you do science at UTS? Well, we have some very unique facilities that other universities simply don't have. For example, on the top left here, you can see the surgical and anatomical facility that we use to teach the anatomy subjects that we run in our pre-med program, for example. Below that is the protospace. This is a large format 3D printing facility where students can create their own prototypes in large format, as you can see here. And that's particularly useful for our biomedical engineering students, for example. In the centre are two unique facilities that we have in the forensic sciences. So UTS has the biggest forensic science program in the country. It was the first to be set up in the country, in fact, and it's ranked probably around third in the world for forensic science research. So the top one is just an image of our forensic taphonomy facility, which is basically a body farm, and it's the only facility outside of the US. Below that is our crime scene simulation lab. So this is where we mock up different crime scenes and train our students how to collect trace evidence from those particular crime scenes and maintain the chain of evidence for legal purposes. The top right is our super lab, and I'm going to show you a quick video in a second from the super lab, so I won't talk any further about that. But below that is the UTS Biologics Innovation Facility, which is something that's very useful in the biotechnology area, particularly in the environmental biotechnology area, where we look at production of recombinant proteins, nutraceuticals, and algal bioproducts. So this is a quick video to show you our super lab, which is one of about 10 super labs in the world. So we're in a very unique situation. It's a very large format, 220-seat laboratory. We have a breakout space there that you could see in the video. The key thing here is that every student has a computer in front of them, and we communicate with the students through a headset and microphone system. So we can run one single class of 220 students or up to 12 different classes of students running completely different programs in biology, physics, and chemistry. We have high resolution digital cameras that can display onto LCD screens as well as the computers in front of every student. Data can be collected directly into the computer, and that's one advantage of every student having a computer in front of them. All the screens are touch or keyboard entry. We communicate through a light system. So you can see here a student changing the blue light to an orange light, which indicates that that group has a question. If the demonstrator felt that that question needed to be answered for the whole group, they would then switch on the blue lights that you could see in the background there, and that indicates that students should put their headphones back on. So the students don't wear their headphones the whole time, only when the blue lights are basically on and they need to communicate with their demonstrator. The next video is actually of our newest super lab. So we are in an extremely important position here at UTS Science, where we actually have 2 super labs. So there's no other university that we're aware of that has 2 of these large format laboratories. So this is a 270 seat laboratory. This is organised quite differently. It's a much more open plan. Students gather around hexagonal shaped desks and carry out group work rather than individual work, as you saw in the previous video. And one of the unique facilities or unique features of this lab is that we can ask students to design their own experiments to answer problems and work in groups, which is exactly what they would do out in industry or in a research environment. So that shows you just a couple of examples of some of the unique facilities we have here at UTS. So what are the bachelor's degree programs that we offer in the Faculty of Science? We have an extensive array of undergraduate degrees. In the School of Life Sciences, we basically have 2 different schools in our faculty, one that looks after human biology and environmental biology and carries out programs and research in the areas such as biotechnology, medical science, biomedical science, forensic biology, as well as our advanced science program for pre-medicine and pharmaceutical sciences. We also do environmental biology, marine biology, and an environmental biotechnology in our advanced science program as well in the areas of environmental sciences. In the School of Mathematical and Physical Sciences, we have both maths, physics, and chemistry, where we cover statistics, mathematics, and analytics. So we have a strong statistics program in research and teaching. It's a top 100 program. And in the physics area, we have a very applied physics program. Certainly do theoretical physics in that degree, but it is very focused around applications of physics. Nanotechnology, which spans the gap between physics and chemistry, as well as biomedical physics in the imaging sciences, for example. We have a very applied chemistry program and medicinal chemistry program, as well as one of our flagship degrees, which is our forensic science degree, which originally started in the forensic chemistry area, but we've since added crime scene investigation and also digital forensics, which we teach in collaboration with the Faculty of Engineering and IT. So just a few words about our advanced science program. This is a slightly unique program for science degrees in Australia. It falls under 2 categories. The first is our research focused major, which is in the environmental biotechnology area. And the structure of the degree is a 3-year program, as all our science degrees. The difference with the advanced programs is that they carry out research projects in all of the last 4 semesters, as well as some key foundation research subjects in the first and second semester. So here students can undertake research projects at an undergraduate level, And it's particularly tailored for students that have got interests in developing research careers and thinking of going on into higher degrees by research, such as Masters by Research or PhDs. The other type of advanced science program is where we replace those research subjects with advanced coursework subjects in pre-medicine and pharmaceutical sciences. So those blue subjects there are replaced by advanced level coursework subjects. So it's a unique program, a slightly higher entry point for this program than our standard degrees, but nevertheless a unique and very rewarding pathway to a career in science. We also have a number of combined undergraduate degrees with other faculties, such as business, international studies, a new program in creative intelligence and innovation, law and engineering. And this is where you combine a science degree with another discipline area. The length of those degrees does vary from, in the case of business, which is one of the most popular, the combination of Bachelor of Science and Bachelor of Business is a 4-year program, as well as our international studies, law and engineering, which are all 5-year programs. The combined degrees are not offered with all combinations. But typically if you undertake the Bachelor of Science, you can undertake a combined degree with any of those discipline areas. So it's often very difficult to talk to students about their careers in science because science is actually an extremely flexible degree and you have an enormous number of options ahead of you if you choose a career in science. It's not as simple as just asking you which areas of science that you're interested in. And I've just pulled out 4 main areas: maths and stats, environmental sciences, the physical sciences such as physics and chemistry, as well as the sort of biomedical and health science areas such as biomedical science. Even when you get down to that level, there are even further choices that you can make as you progress through your degree. So as you start off in first year and you take a liking, if we're to pick, for example, the biomedical science degree, and you like microbiology, well, you could take elective subjects in the microbiology area as you progress through the degree and become a specialist in microbiology. But if you didn't like microbiology, you might pick some pharmacology subjects and become a pharmacologist. So it's very hard to talk to you about where your career may end up because of the flexibility that's built into our programs and degrees. So to help you, we have a little booklet that you can download from our website, and the details are over here in the black section, which is our Science Careers Guide. And I've just pulled out 3 examples here. The guide actually has all our degree programs. And I'll just pick biomedical science for an example. So you can see here on the left, this applies to our Bachelor of Biomedical Science and our Bachelor of Science, which does actually have a major in the biomedical science field. And what the Careers Guide does is to give you the possible jobs of graduates that come out of these degrees. Depending on what majors they choose, they could end up in any of those types of jobs. And using data from some of our alumni, you can see where those graduates have actually ended up. In your country, there may not obviously be these individual companies or businesses, but there will usually be an equivalent, particularly in the government areas or with multinational companies like KPMG or Deloitte or PricewaterhouseCoopers, for example. So please download that. You'll find it a very useful guide to help you understand what your career might look like. After you graduate from your degree, you're very well armed to gain good employability. UTS is well known for its graduate employability ranking. We are a top 100 university in terms of our global ranking of employability for graduates. We actually rank currently 7th in Australia in that ranking. So I've just tried to show you a few examples here of why you should choose science at UTS. We have a quality teaching program. We've won world awards for our teaching programs in 2015. And all the academics that teach in our programs in science have to undertake research. 40% of their time is actually undertaking research, and that feeds into our teaching programs. We have good liaison with industry as well in the development of our degrees. We've got some world-class facilities. I've shown you some examples there of particularly the super labs and the forensic taphonomy facility. We have good support for internationals. We have a range of different competitive scholarships. For example, the 25% tuition fee waiver that we have in the science undergraduate degree, as well as full tuition fee scholarships. And if you're interested in looking at that, there is a separate booth for scholarships, or you can look on our website and just type in international scholarships in the search engine on the UTS website. If you come to us with some prior knowledge, some prior undergraduate like programs, say for example, a diploma, you are likely to gain credit recognition for some of those subjects. We also have on-campus accommodation options, which is right next to the science building. And I'd encourage you to look at the booth that covers our accommodation options. So we have very practice-oriented courses. You might have noticed that I highlighted that particularly in areas such as chemistry and physics, we run applied programs. We work in collaboration with business industry to develop those types of programs so that they will be highly attractive to those employers. And we have quite a large range of industry-based internship as you go through your degree, and a lot of the subjects have work integrated learning opportunities. If you wish to undertake a semester abroad, you can do so for credit towards your UTS degree with many of our partners. We have one of the largest student mobility programs in the country with over 250 different partners. And we also have internship opportunities internationally, and you can work with our build team to develop leadership skills in that space. So to conclude, UTS Science actually is very research oriented, and we actually contribute about 35% of UTS's total research output. And UTS is actually currently ranked #1 in Australia for the impact of our research at both national and international level. So if you were considering going on to a higher degree, then we also have programs for you, and I would encourage you to listen to the postgraduate coursework and research webinar that is being recorded. So thank you for your time. If you have questions, please enter them into the Q&A section in the webinar, and we will attempt to get through as many as we possibly can. If you think of a question afterwards, after the webinar is finished, then please don't hesitate to contact us on our email, which is science.international@uts.edu.au. Send those questions through and we will get back to you in due course. So I thank you for your time and your attention, and I wish you good luck.